I'd like to start this with a small selfie with the audience, if you don't mind. Anyone minding having this awesome moment with everyone on Twitter? Let me see, how can I? Yeah, so all good? Let's try. Maybe you can come over as well.
You're famous.
Yeah, sure. So, cheers. All right. So this is going on Twitter under WeAreDevs hashtag, and welcome. All right, so my name is Mahdi. I work as a developer advocate for Vallon, and I'm so excited to join you here after the amazing talk by Steve. And yeah, I'm going to talk to you about offline first design and also about web components. So ready? Should we start? I see a huge room, so you don't see what I'm seeing now. So that's why I'm kind of hesitant. Should I start or should I wait to hear from you first? Awesome. Yeah, let's start. All right. So I have this interesting approach where I start with some design concepts, because I'm talking about design here, which is related to development after all. And in this design concept, I'm asking a very interesting questions, like this one, for example. When a new Android device being announced in the market, we see a huge hype in the tech community, and a lot of tech people start to get interested in it, especially because the specifications are very nice. Like we see huge RAM and processor power and stuff like that. From technical point of view, we love them. But if we compare an Android device with such specifications to an Apple device, we're going to find that an Apple device can be drawn like this, right? But the interesting point is, so how many of you are not technical, like not developers? 2, 3? OK, so I'm talking to the right audience, because now if we go in the street to a random person and give him or her $1,000, and then we ask them, this money you can use to buy a new smartphone. What kind of smartphone you think they're going to buy? Is it an Android device or an iPhone? iPhone, right? Most likely. I mean, I'm not trying to advocate to anything right now, except that most likely people, if they got free money, they're going to buy an iPhone by default. And what is the reason behind that? The reason is very simple. User don't care. User don't care about high processor. User don't care about big RAM, security, all these kind of things. From user point of view, they just don't care. And this is my first note for you. So when you are developing an application, what should you take care of? Is it the technical specifications or to develop something that just works? My second example for you is Amazon. So Amazon, for, again, most of the technical people over here, is probably servers with nice infrastructure, cloud solutions, stuff like that. But for the other side of the world, Amazon is a nice drone that delivers things in front of your house. Actually, for some other people, Amazon is a nice place in Brazil. So it depends. Now, when you're developing something, what is your target audience? Are you targeting technical people who knows that Amazon is a server? Are you targeting people from America who have drones to deliver things? Or are you targeting the whole world? So we at Vallon, we have this problem. We are targeting only developers, this small orange portion. So we are Vallon, we are our target audience are technical people like yourself. We're developing UI components. But do you really want to do like us? Or do you want to target the whole world? And the whole world, which means that anyone who uses internet. Of course, it's something that differ from one person to another, from business to another. Maybe your business is like us, you target technical people, or maybe you should really consider putting some more effort into your target audience when developing something. So get out of your comfort zone. Get out of what is your familiar tools that you just know how to develop with, and think first about what your user want and where your audience is. And my third example for you is these little nice Twitter applications. So can someone tell me what is the difference between those two? By the way, those on Android, because I'm a fan of Android users, so I'm not telling you to use iPhone or anything. Both of those are running on Android. Can somebody spot a big difference between them? Language, yes. Something else? Sorry? Color, theme, yes. Actually, both of them are running on my Android device exactly at the same time. The only difference is that the first one is a native Twitter application, and the second one is a progressive web app. So more about that. The first one is my native Twitter application that most of you are using. And let's talk here from a user point of view when a user starts to use Twitter for the first time. So the user will go to App Store or Play Store and download some kind of 25 megabyte of data or something like that. And then if you're running a little bit on older version of Android, it's going to ask you for many permissions at once. Otherwise, it's going to iteratively ask you for permissions, give camera access, hardware access, and so on. And if it's the first time ever to open the application, then thank you. So if it's the first time ever to open the application, then you will not have the features of autofill, which means that you will have to remember your username, password, all these kind of things. And even if you did, then eventually installing other apps is going to make an issue for you because you will not have the remember me option and having cross apps saving information. Also, the same issue applies if you're, for example, registering for Twitter for the first time. So filling the first name, last name, address, and so on. Also, eventually, the app needs to be updated, and every single time when you update the app, you're going to download some kind of data every single time. So those all the things that you're going to face when you are using a native application. And from a developer point of view, or from business point of view, it's costly to develop a native application because you need to develop it for iOS separately, for Android separately, and eventually for web interface. Now, when I compare this with a progressive web app, I'm going to explain what is progressive web app eventually, but let's just put it like a web application, a mobile web application. So a mobile web application, when you open it for the first time, it just downloads the needed data. You don't really download everything at once. Hence the name progressive, because it progressively understands the user. Also, it doesn't ask you for permission from the first use. It progressively asks you permission whenever needed. And because it's a web app, it has the autofill capabilities, it has the remember me capability, and also because it's a web app, it's guaranteed to always be running the latest version. From developer point of view, this is excellent because you don't have to worry about managing multiple versions of the app. Every single time your user accesses your application, they get the latest version. And since you are using the platform, the web platform, then you have everything on the same place. When I mentioned 24 megabyte over here, maybe many of you thought that 24 megabyte is not a big deal. But think about it. If I give you a home page that takes some time to load 24 megabyte of data before loading the home screen, would you wait for that? Would you be willing to wait for such a screen to be loaded? Most probably no. So 24 megabyte is actually not a small number. And think about how many times you have to re-download this after every single update. Many people will wonder, so maybe I'm talking about getting away from native platform and native development and these kind of things. Maybe I'm talking about cross-platform tools. Let's put it that way. Maybe I'm really talking about cross-platform tools. But then what is the problem? We are here talking about our user, and the user doesn't care. So the user doesn't care if you give him or her an application developed in C++ or even in assembly. Putting a big label on top of your application that it has been written in assembly will not attract the user, right? But making an application that just works is the attractive point here. This is a little bit modified version of a a comic that's taken from KXCD that's talking about a famous problem that all of us are facing nowadays when we're downloading many apps and trying to get the whole Play Store installed on our phone. And basically, the solution has been floating around many years ago with the rise of cloud. So many years ago, they told us cloud is a solution, and cloud proved itself that it is really a good solution to get rid of desktop applications. Many enterprises moved from native executables, exe files, to cloud, and they showed a huge success in that front. And now it's time for native mobile apps. Some of them, I'm not saying all of them, but some of them, or most of them, need also to be reconsidered to be moved to the cloud. And my third design note for today is what you should care about more. Using fancy Kotlin, iOS, Swift, all these kind of languages, or caring about user experience first. Now, talking about user experience and mobile web, there is a bit of struggle in between. We have known all the time that a mobile web application is not really smooth, but sluggish, doesn't have all the capabilities. Luckily, a definition has been made for this to solve all those problems and fix the gap between native development and mobile web applications. That's called progressive web apps. So how many of you heard about progressive web apps? Awesome. So probably 50% of you here, but for the other 50%, progressive web app is not a new development language. It's not like a new framework that you have to use for your daily development. It's just what I like to call a checklist of items that you need to put into consideration to have a progressive web application. Now, those things, you might have some of them already in your current application, or you might be applying many of those aspects, but it's good to have this checklist in place and go over them and make sure we are applying them so that you guarantee higher user acquisition. One of the very good things is the service worker, for example, that allows you for caching and background synchronization and sending notification. Basically, most of hardware access is now possible thanks to service worker. And with iOS, the latest version, we can see that even service worker now work on iOS, so probably all the problems are now fixed. Also, developing an application that is fast and not sluggish, and all these kind of things are good approaches that we need to follow. But my top things that I like to highlight is the offline-first design. Because we're talking about a mobile web application, and whenever we say the word web, every single thing that pops in our head is this little nice dinosaur that jumps and shows whenever we go offline. For example, going offline can be as simple as flying or going underground or something like that, but it can also happen with just losing the signal, just being a little bit away from internet connectivity. Nevertheless, I love to highlight also the fact of using web components, which is a way to modernize how our web applications are developed. So web components. Web components has a very nice introduction that tells you how or what is web components, how to develop web components, and so on. But I like to introduce web component in this very little interesting picture. So this is actually the video tag. It has been introduced in HTML5 many years ago, and it's now native in all browsers. But the interesting fact about the video tag is that it actually contains something called shadow root. It consists of sub-tags, a set of tags that are included inside the video. So you as a developer, you just write video tag inside your browser, and that's it. But the browser actually render it in terms of many markup tags. And now the capability is given to you as a developer that you can define new markup tags and reuse them across other applications. And that's actually what we have done at Vallon. So we have changed the way how we develop UI components from just specific to a very specific framework to make them standard so that you can reuse them and enjoy some of the object-oriented capabilities across platforms. So this is a small use case that we have experienced at Vallon. And here I'm talking about open source web components that we have developed. So before, what we had is a set of components that only work with our framework and only our framework. And whenever there is an add-on, then those add-ons are only specified for our framework. And you need to be expert in how to develop this specific kind of components to be able to know how to modify them, test, debug, and so on. But after we changed our components to web components, then because they are standard, they give us two big advantages. The first advantage is that our components can be used with pretty much any framework, whether it's Java or non-Java framework, Angular, Vue, React, you name it, you're going to find it to work. And also, it gives us an advantage that anyone out there that develops a standard web component can work with the framework. So our set of add-ons is no longer limited to only add-ons developed for the framework, but pretty much any standard web component. And now there is a nice separation of concern. So it's a separation between whether you are developing a specific component for the framework or just developing it generally as a standard web component. So this is a very interesting use case that I'm shouting out to any framework developer or anyone who is using any kind of framework to reconsider using web components as a way to move forward with the web platform. And by definition of web component, they come to work offline. So they come with aligned with the capability of working offline with the offline design. And the main reason I'm stressing on the offline first design is because it's the only way to guarantee 100% always-on user experience. So as I said, you don't want to lose your user. Your user will go under the tunnel, for example, or your user will just lose connectivity at some point. And if you can maintain reusability of the user and not losing the user at any point, then the user will love your application regardless of what programming language you have used or anything like that. So how to do that? What is the technical solution for developing such kind of things? The first approach is very easy and straightforward, just caching, right? But there is a small problem with caching. Anyone can spot it? Validation? Well, you have to open the application at any point. But there is a small problem with caching is that it doesn't work with dynamic applications. So maybe if you have a static web application or something like that, you can basically just cache all the pages and your problem is gone. But let's assume a very small, simple contacts application. Now, when I click on a contact, I want to open a form that displays the picture, first name, last name, email, website, and so on. And I want to also be able to modify the user and save to be able to see it later. So those kind of modifications and interactions need to have a little bit more sophisticated interaction more than just caching. So some kind of probably database or relational database that is stored inside the browser where we can relate to it. Luckily, there is offline storage, and probably most of you know about it already. We can use the browser storage, the IndexedDB. We can use it, and we can store the data in it. But the offline storage has, again, a problem, which is data replication. Now, we modified the data, for example. I opened the contact and made a small modification, and then clicked Save. How to make sure that the offline storage goes back to the server? So across the internet, there are many, many solutions talking about data replication. Even Google developed many approaches like Love Field, for example. Anyone heard about Love Field? No one? Yeah, that's very understandable because the project is dead now, because Google is not like pushing forward for it. Instead, they are pushing towards Firebase. So the story behind Firebase is it was an independent company that basically provided this data replication out of the box, and they were only specialized in this, but later on got acquired by Google, and then the wonder started to happen because many enterprises refuses to have their data stored at Google servers for some reason or another. But also, Firebase, as sweet as Firebase can get, as they have a small problem, which is basically if you have any kind of database, let's say Oracle database or MySQL database or MS SQL database, you cannot use it with Firebase. Firebase forces you to use their own storage. That's why there is luckily many other open source solutions available across the web, and my favorite is PouchDB. So again, there are many solutions, but based on my personal experience, I found that PouchDB, an Apache 2.0 solution available that's basically solving all my struggle, and the way how to develop with PouchDB is simple. If we consider this small device as our front end, or our web application, you move all your transaction and you move all your interaction to the PouchDB. And then PouchDB will automatically perform bidirectional data replication between the client side and the server side. So it removes all the struggle for you. And you have two options. Whether you are starting from scratches, then you use PouchDB, which is fine. But if you are migrating from an existing solution to PouchDB, then you need to remove all the connections between the client side and the server and make it redirect towards PouchDB and make PouchDB take care of everything. Now, because of the nature of PouchDB that is open source, you're going to find plenty of plugins available in the community with many contributions on how to connect back the layer of the server with whatever kind of database. As far as my tests, I have tested this with many servers, and like Oracle Cloud, and I also tested with Hookle. So this kind of test works great for me, and the database itself can be MySQL database. That was my test. So what will happen here? Now we have the upper part, that is the server and the online part, and the downer part, which is our device. Now, if you lose connectivity, there is no problem, because your all interactions are going to PouchDB. So PouchDB can still serve your data, and you will be able to modify the data offline, and you will be able to do pretty much everything regardless of connectivity. And when you get connected again, then PouchDB in the background synchronization gonna automatically synchronize the data back to the server for you. You don't really have to worry about that. One little advice, though, is that to make the PouchDB inside your server worker so that it can work even if the application is not open. Now, very, very quickly, I will go over the demos that I have for you. By the way, the demo is available on GitHub. I think I need to. Yeah. So if you go to my GitHub, you're going to find this offline first app, which is an interesting app with, this is how it looks now, so it's a little bit updated, and this is how it looks on mobile devices. And I have also included step-by-step on how to migrate generic application from using a normal database to offline storage. So maybe I can just jump and show you the application, increasing the font. So this is the application, basically. It pretty much does everything. It does the search, something like this, for example, and it does the modification, so you can say update and so on. And as you can see, pretty much all the components that I have used here are web components. So this is a good model on how to use web components and how to also make offline storage. Again, if you are interested, this is the project. Maybe you can follow it so that you get updates and to see what are my tests on several platforms, like I've mentioned before, and several cloud solutions. But if I want to go quickly to end this presentation about my demo, my challenges. So as you know, every solution introduces more bugs or more challenges, right? So my challenges that I'm aware of up to till now with this kind of solutions is the initial load, for example. So I kind of tricked or lied a little bit when I said that you can just store everything inside the browser. But this is actually not a good practice. So in big applications where databases are kind of 1 terabyte of data, you don't want your user to wait for 1 terabyte of data to be downloaded first, provided that the user has 1 terabyte of available storage. So what you need to do here is basically to optimize a snapshot of whatever data needed to be provided for this specific user and continuously get rid of unneeded data and only store needed or relevant data. The second challenge is security of stored data, because the data is now stored inside the browser. And any clever developer who is opening the developer tools will be able to see all the data. So it's your responsibility to make sure that this data is invalidated or encrypted when the user is logged out. It's not your responsibility to make sure that this data is secured if the session is still active, because it's similar, for example, to opening my Facebook and giving my open Facebook to a colleague. I have given him or her an access to my Facebook. That's clear. I cannot do anything about that. But if I click log out, then it is your responsibility to wipe the data. But also, it's not your responsibility to protect across the domain. So luckily, browsers will make sure that data stored from your own domain will never be read from other domains. And finally, the third problem is the race condition. So let's imagine that I opened the application, and I started to make a small modification, and the gentleman here started to open the exact same application. But I went offline, and he is still online. He clicked save, and after a few minutes, I clicked save. What will happen when I go back online and my data tries to get synchronized? We're going to get a clash, right? So this is actually a situation that we will all face, even if both of us were online. What will happen if he was online and I am online and he clicked save 1 second before me? The same exact situation will happen. The only difference here is that the likelihood of this situation to occur when you are offline is higher than when you are online. Luckily, PouchDB provides some kind of solutions, like something called best guess merge. For example, if he changed the first name and I changed the last name, maybe this data can be merged. But otherwise, again, it's your responsibility to architect this kind of situation and fall back to a screen when data cannot be merged. Final design notes for you, how to practically test that your application is ready for the market. The first note is develop a mobile-first with a mobile-first approach. The mobile-first approach means that please test on your mobile device. We all love to use our browsers. We all love to test on our device and emulators. But that's not really going to give you a true impression of the final application. If you test on your mobile device first, then it's guaranteed, trust me, that it's going to work perfectly on your desktop device. The second note for you is touch-first design. So your user has big thumb, so please make sure not to put a small icon on the top far corner, because the user will not be able to reach that corner. Make sure to make all buttons big enough, and don't put things close to each other. And finally, the coffee-first design, I came up with this approach, which means that if you want to really test how useful and the user experience of your application, basically give a cup of coffee to your tester and open the application on the other hand and see if your tester gonna spit the coffee on the mobile phone while trying to use the application. If the user managed to use everything with one hand without not using the other hand, then you are pretty good to go. If you don't like this approach, maybe you can try with driving. So see if he can use the application. Please don't do that. So I think that was everything. Again, this is a GitHub for the application that I showed to you. I have another link that shows you how to get PWA capabilities inside the Java application. But that's pretty much everything. So thank you.
Thank you very much, Mahdy. That's great. So I know we're holding you up from lunch slightly, but I'm going to ask you one really quick question. Sure. OK, because you've been asking questions. My question is this. Do you advocate the use of web components as a replacement for JavaScript frameworks like React, Angular, and so on? Do you think that's a good use case?
I advocate that all JavaScript frameworks should use web components by default natively. Instead of React creating their own React components and Angular create Angular components, I advocate that web components should be the default manifesto for all the frameworks, and then you can use them across platforms. Again, if you are interested, please go to my GitHub, github.com/Amahdy, and you'll find demo application on how to use web components with pretty much many frameworks, or the famous frameworks like React, Vue, and Angular.
OK, thank you very much, Mahdy.
Thank you.
A round of applause.